Well, it's Monday. It's fourth week. I've posted a homework assignment, homework 3. That's available online, and I realized I didn't post one of the data sets that you needed, so I just posted that like half an hour ago. Okay, so if you tried to do problem number 2, you would not have been able to do that until the last half hour when I posted that data set, but it's there now. And a lot of it covers tidyr and dplyr, and then also you'll have some exercises with rvest and regular expressions, and so that's what we'll cover this week. So we covered rvest last week, and so you can at least take a look at that portion of the assignment, and then today we'll cover tidyr and maybe dplyr. We'll see how far we get, okay? Maybe this lecture will continue on Wednesday. Yeah, we'll see. And then, and as far as regular expressions go, that will come later this week as well. So, so all of that. Okay, I am stealing or just borrowing or using the slides that Garrett Grolmund has created. He has done a good job with explaining tidyr and dplyr, and so if his slides are really good, might as well use them, right? He's a data scientist and master instructor, so who am I to disagree? Okay, and I've posted links to his GitHub where these slides are posted, and you can follow along. That's not me, that's Garrett. But we will look at these two packages, tidyr and dplyr, okay? And there are cheat sheets. They actually updated the cheat sheets for data wrangling and whatnot. And so this is going to pop up here. So definitely go to RStudio cheat sheets and download this stuff here. So the tidyr is now part of the data import cheat sheet, and dplyr is the data transformation cheat sheet. So so you can take a look at that. Okay. He talks about tibbles, and he says tibbles are just like data frames, but they play better with the console window. And in fact, if you, in dplyr and stuff, when it says the object is of class tibble, if you look at the attributes vector for class, it's actually going to say tibble, then data frame, and whatnot. So pretty much all of the methods that apply to data frames will still work on tibbles as well. Okay. The biggest difference is that with a tibble, maybe you have experienced this in R. Let me just do a library dplyr here. If we do something like is it gas mileage? Is that the, I forget what it was. Okay, never mind. I don't know what the data set is, but. Okay, sometimes you will have a data frame that's maybe too big for the screen. So if I shrink this down and I say empty cars, it's gonna like print everything, and then it breaks it across these things. If I throw this into a tibble, what am I doing? Is there no as.tibble? There's no applicable method for, let's try this, as.tibble on empty cars. Okay, so with as.tibble, what it does is you'll notice when I just type in empty cars, it kind of tries to dump the entire data frame onto the screen with, and you have to kind of scroll through all of this. If it's a tibble, then it kind of it sees how big your console window is, and it prints just what you can fit in the console window. And the things that do not fit, it will say there's 22 more rows and 3 more variables, AM, gear, and carb, okay? So tibble when you have things as a tibble, it just plays a little bit more nicely with the console window here, okay? Rather than trying to dump out the entire thing. Now, sometimes you want it to dump out the entire thing, and you don't want it to truncate after 10 rows. So there's a few ways you can do this. One is you can just say, as a data frame. So, if this is treated as a tibble, then you can go just do as.data.frame, and then it will revert back to its data frame method of printing out the entire thing. Okay, so that's an option. But otherwise, tibbles work nicely with the console window. Okay, and I think we're familiar with View. When you load up a data set, you can just kind of click it, or you can do capital V View, and it will try to put the with RStudio, it'll show it up in the corner and whatnot. We've already talked about pipes as they relate to RVEST, so I will go ahead and skip this portion of Garrett's slides. But basically, instead of having to specify select from table TV, we're going to do the columns child through elderly. We can just do TB pipe into select. Okay, so we've got that. Okay, so let's talk about data wrangling, which is all about taking in a little bit of messy data and turning it into something that we can work with. Okay, Garrett says maybe this is 50 to 80% of your time. I guess it depends really where your data sources are coming from, right? If your data sources are clean, then the number's going to be lower. If they're messy, then yeah, it could be a lot of time spent there. Okay, and the biggest goals of data wrangling is to make it suitable to for analysis and to reveal information. And so tidyr is really focuses on this part. dplyr focuses on the second part. Okay, it says data sets come in many formats, but R just prefers one. And so for the data sets that we're going to take a look at, we're going to use this package called EDAWR. It's like Expert Data Analysis with R, except it's not readily, it's not like you can just do install.packages EDAWR. You have to do install_GitHub, okay? I've kind of copied a lot of the command lines that you might use into the R code on today's CCLE page, so you can download that and follow this along. But anyway, we'll load up this data set, library, EDAWR, and we can take a look. Storms is from hurricane data in EDAWR, and we've got the cases data and pollution and TB, okay? And we can look at the help files for each of those. But we'll start off with each of these things. And if we take a look, I'll just show you. So here we got storms, and we've got cases. This is what they look like. And pollution, this is what they look like, okay? So as far as storms go, this is, if we look at the variables that are in the storms table, okay, the variables there are storm name, wind speed, air pressure, and the date of the storm. Okay, so we've got 4 different variables, and each variable has its own column. So this is what we would consider tidy data. If we look at the cases table and we ask what are the variables that exist in cases, there are really there are only 3 variables. Okay, one is the country, another one is the year, and then the last one is the count that appears. Okay, and they are not arranged in the form of 1 column per variable. Instead, country is in 1 column, but then the values for year form column headings, and then the count gets kind of spread out over each of these things. Okay, and then if we look at the pollution data set, okay, we do have the variables city, particle size, and amount, but if we look at this, we've got New York, New York, London, London, Beijing, Beijing. We got those things kind of repeated. So it's not really one observation per row. Now it's like you've got 2 rows per observation. And if we try to think of, well, what would this data set look like if we had 1 observation per row, then the actual variables that are there would be the city, and then one variable would be the number of large particles, and the other would be the number of small particles. And that would allow us to have a data set where there's 1 row per observation, 1 column per variable. Okay? And so the goal is to get everything to look like this, where you've got 1 observation per row, 1 column per variable. Okay? So tidyr allows us to handle data that do not look tidy. Okay? It looks either like this or like this. And how can we reshape our data into a form so we have 1 observation per row, 1 column per variable? That's the goal that we want to have. Okay? And the reason, and this is, so, sorry, before we go on, one of the reasons why we want that is because if we just wanted to select one of the variables, when we have it in tidy form, all we have to do is use the $ form, and you can say, I want the storm name, or I want the wind pressure, wind speed, or the pressure, or whatever, and you can just do this, right? If you want to get the values of the variables for something like this, it's a lot more messy. You have to do some subsetting, you have to unlist, I don't know, all of this nonsense. And over here, you've got to, really subset the odd rows or the even rows. It's, it's not a fun thing to do. Okay. Another benefit of having things in tidy form is you can use the vectorized operations of R. So, for example, if you wanted to calculate the ratio between air pressure and wind speed, you could easily do that by using R's vectorized operations. Just do storms $pressure divided by storms $wind, and R knows to match up each of these things. It has the wrong number. For whatever reason, it has the wrong values here. But basically, 1010 divided by 45, 1010 over 50, and so on and so forth. It can do those operations rather quickly if the data is in this tidy form of 1 row per observation, 1 column per variable. Okay, so this is what tidy data looks like. Okay, and this is, if we're going to be dealing with kind of rectangular data, this is how we want our data to look. All right, so this is good. Tidy data is a good thing, and in fact, it's so good that Hadley Wickham has named kind of all of his, not all of his packages, but a lot of his packages belong to what's known as the tidyverse of R, in that it's several packages that make analysis of tidy data, really, really good. Okay, and so I would say tidyr and dplyr really form the foundations of the tidyverse, and pretty much, the other packages like ggplot2 and all of that kind of play into that. Okay, the 2 biggest functions that we will use will be gather and spread. Those are our 2 primary functions in tidyr that allow us to transform data that look like this or this into tidy data. Okay, so we've got gather and we have spread, and you can always look up the help there. Okay, if you haven't done so, you'll need to install the package tidyr. Okay, so it says if we were to reshape this data into tidy data, okay, how many columns would it have? What would those columns be, and how many rows of data would we have? All right, so what would our columns be? Country, year, and N. Okay, that's kind of given to you. So we have 3 columns. How many rows of data do we have? We have 9. Okay, and this is what it would look like. Okay, so we would take this country, France, and all of this, and we would have country, year, and N, and we would take this first observation. France in the year 2011 had 7,000. Germany in the year 2011 had 5,800, and so on and so forth, and we would populate our data like so. Okay, we would have a total of 3 columns, country, year, and number of cases, and we would have 9 rows here. Okay, and now we have 1 column per variable and 1 row per observation, and the verb that we use, or the function that we use to get data from this set, is called gather. Okay, why is it called gather? Because we are gathering data that is spread across 3 columns, and we are gathering these values into 1 column. So we've got values that are across 3 columns, and we are gathering them into 1 column, into this N column. Yes, question?
I think this is still the type 3 data type.
Yeah, okay, that's a valid objection, okay? Because there's definitely a relationship between the two, okay? So that's a valid objection, but let's say this is the form that we wanted to deal with, okay? If we wanted all of the N values in 1 column, we would do it this way, okay? 3 columns, the data that is across 3 columns, we're going to gather into 1 column, okay? All right, so how do we do this, okay? If we want to gather these 3 columns, so which is, in the original data, is columns 2, 3, and 4, okay? So we're going to take columns 2, 3, and 4 and gather those into 1 column, all right? So the way we're going to do this is we're going to say, okay, the column headings, 2011, 2012, and 2013, those will become the key column here, okay? So we don't want to throw away this information. We want that to go into this. So we're going to store those values, 2011, 2012, and 2013, here. This is called the key, and then the values over here get gathered into this 1 column N. So we got the 2 parts you need to know are the key and the value. And this is how we're going to do it. We're going to say gather, and this is the table that we're dealing with, cases. This is just going to be the name of the key. We're going to call it year, and this is going to be the name of the column that we've gathered. We call it N. Okay? We have year and N, and these are just arbitrary labels. If I want to call this Y and I call this number, that's fine. Okay? It's text labels. It doesn't matter. There's no actual inherent meaning to these words. They're just text labels. You want to call this is the year that, I don't know, you wanted to have a super long string, that's fine, okay? And then the last bit is just which columns are being gathered together. Okay, which columns are being gathered together, and it's columns 2 through 4, which is what we saw here in the original data set. Columns 2 through 4 are being gathered, okay? Okay, so it says data frame, I guess I should have been tapping the keys to advance, but yes. Okay, so this is just a character string for year and N. They are just names, no inherent meaning, and these are the indices of the columns to collapse together. And when we do this, this is what we get. We get gather, cases, year, N, 2 through 4, and it looks like that. Okay, let's just do this in R. I know it's, you saw it right here, but okay, so here, if we look at the cases table, it looks like this, and then if I click gather, columns, okay, so here's our cases table, and let's gather these columns, and it has gathered those values just like that. What would happen if I say gather just columns 3 and 4? So look at the original data. We've got country, 2011, 2012, 2013. And this time I'm saying I only want to gather columns 3 and 4. What's it going to do? It's going to gather columns 3 and 4, yeah. Okay, the resulting table would have how many rows? 6, okay? And so what would happen to these values, 7,000, 5,800, and 15,000? They stay there, but they get repeated across all 6 rows, okay? So what we have now, so I've gathered columns 3 and 4. Let's just compare this to the original cases table, okay? So we gathered the columns 3 and 4, 2012 and 2013, okay? And so we can see, yeah, 69, 60, 140, you know, those go there. 70, 62, 13,000, those go right there. And then these values, they just get repeated across. In the same way that France, Germany, and US got repeated, the columns that were not gathered just get repeated across the board. Can you see how this went from here to here? Is that okay? It feels a tiny bit uncomfortable because you're like, well, we should have gathered the 2011 through 2013. Yes, absolutely, we should have. But you can imagine a data set where you've got other things, like in our cases table, if I inserted a column that said, I don't know, capital, right? Country capital or something like that. That's not something we would gather in with the rest. And so that would be repeated just like the name France, Germany, and US, okay? And so just like that, those just get repeated and are not gathered if you didn't specify that. Is that okay? All right. Okay, so that is gather. So we've taken information that's across several columns, we've gathered them into one column. Okay? What if we want to go the other way? All right? So now we have information in one column, right? It says amount, but we want to spread these across 2 columns. We want one of those resulting columns to be number of large particles and the other one to be number of small particles. We have a question there.
To be clear, with the last line of code, cases, the name of the data set?
Yeah, cases is the name of the data set, exactly. Yes?
So how would you do that? How would you use the gather function if you wanted to use the variable name or like the Can you do that?
Yeah, that's exactly what it does. Here, so let's just look at this. Okay, so we've got cases. The variable names are 2011, 2012, 2013. And if I just say I want to gather this, cases, we're going to pipe this into gather. That one column is going to just be the year, and the other will be number of cases or something, you know, and then we're going to gather columns 2 through 4, okay? That's all it does. 2011, 2012, and 2013 get preserved as the values that go into the key. So the first thing that we put in key is the name of the column, of the key column, and then over here is the name of the value column, okay? So again, there's no inherent meaning to these text strings. That you can choose whatever you want. So here I've got Y or cases or whatever, and these column names become now entries in the key column. Yes. Oh yeah, yeah. You could say 2011 through 2013. You can also do this. Okay. So yeah, you could use the name of those columns rather than saying columns 2 through 4. Yeah, exactly. Okay. Are we okay with this? We saw this. Okay. So yeah, this way. Now we want to do it this way. Okay. So what would this data look like? How many columns would I have? I guess the answer is here. City, large, and small. All right. Well, how many rows would we have then? 3, right? 1 for New York, 1 for London, and 1 for Beijing. Okay. And so now we have 3 columns: city, number of large particles, number of small particles, and then 1 row per observation. And this is called spread because we are taking the values in one column and spreading them out across multiple columns. Okay, so what we need to specify, now it's kind of the opposite. This is the key and the value, all right? So it's like the inverse of gather is spread, okay? And so this time, we're going to say, we're going to take the table pollution, and we want to take the column size, that's going to be the key, and then the values that we're spreading is in the column amount. So here we have to give names of columns in our original data. So here, size is the column that has the keys. Value is the name of the column that has the amounts that are being spread. Okay? So again, data frame to reshape, column to use for keys, column to use for values. So let's just let's try this. So if I look at pollution, this is what it looks like. I got city, size, and amount, and then I would just do pollution. We're going to feed this into spread, and the column I want to use as keys will be spread. The column that I want spread is amount, and it works that way. It's case sensitive, and it only it only can do this if everything's kind of spelled out the same way. So let me just kind of modify pollution a tiny bit. We're going to just modify. I'm going to change this word right here. So that's in row 1, column 2. We're going to change that to capital large, like this, okay? So now if I look at pollution, it looks like this, all right? It looks like an innocent little change here, right? New York, now I've got capital large and small here. And let's use the same command that I did here. I'm going to do spread, size, and amount. What do you think is going to result? How many columns will I end up having? Let's take a look, okay? So what we see here is we end up having 3 columns because it's looking at this column size, and it says, how many unique values do I have? And it says you've got 3 unique values. You've got lowercase large, lowercase small, and capital large, okay? And so each of the unique values in this column size, which is my key column here, gets its own column in the resulting table here. So what happens is Beijing gets a value for lowercase large and small, okay, and it has no value for capital L large, okay? Meanwhile, New York has no value for lowercase large, but it has a value for capital large here, and so the values show up that way. Does that make sense? How changing that from little l to capital L, how that affects it? Okay, let me undo that thing. So we'll go back to lowercase large, and so if I spread pollution, it looks this way. And then likewise, if I change one of these names, so let's change the name of New York over here to NYC, okay? So if I do pollution, okay, like this, and then I go and I feed it into spread, we're going to spread size and amount. How many rows and how many columns will I have? How many columns will I end up having? Okay, so let's just keep, so this is what I had when everything was spelled correctly. I had 3 rows, 3 columns. Now New York appears under NYC and New York, okay? So what's this going to happen? We're going to end up having 3 columns, okay? But I have 4 rows. I've got a row for Beijing, London. I have a row for New York and a row for NYC. And New York has a value for small, and NYC has a value for lowercase large. But it's missing the other there, okay? So, yes, question?
I have a question. So you're constantly using the typed-in way of writing the functions. So
Yeah.
instead of like
No, there's no advantage. I could just as easily do spread, pollution, size, amount.
they're basically the same, right?
They are exactly the same.
Just
Yeah.
the habit, personal habit.
after I started using pipes, I find myself just taking the name of the data set and starting there and then starting to pipe it in, rather than calling it here. So I just find myself taking the name of the data set and just starting that with my beginning pipe. That's just kind of a habit that I started doing, but there's nothing right or wrong about that. Okay. Yeah, I mean, Garrett puts the argument in here. Okay, and so again, you pointed this out that when we take spread, we would take, you know, kind of data of type 3 and we're turning it into data of type 2, or if we have it in this form and we gather it, and then it kind of turns it in this way. So we can go from one form to the other, either using spread or gather, depending on our needs. So when we took the cases table and we had the columns 2011, 2012, 2013, and we gathered them into one, we're effectively turning it into data of this form. Or if we're going to take this and we want to spread it out this way, that's also a possibility. And so there is definitely a relationship between gather and spread. And, you know, it just kind of depends on what your needs are of the data that will decide which are the variables that you want to have, right? Because the goal is to have one variable per column. And depending on how you're working, perhaps you want to have the data this way, perhaps you want to have the data this way, okay? And tidy allows you to kind of switch between the two forms. Are there any questions on this? Having data in tidy form. We are okay? Okay, there's unite and separate. These aren't that big of a deal. It's basically, you might have like data where you could look at this date, and the date you want to parse out into year, month, and day. Or, I don't know, maybe you have a file name, or it's like homework number, first name and last name or something, and you want to take that file name and you want to split it out into 3 chunks or something, okay? You know, that's going to require that everything is written in the same format, and then you can do unite and separate, okay? So separate will take stuff in one column and split it out, okay? And you can look at the usage, but basically, which is the column that you want, what are the resulting column names that you want, and how are they separated in the original column? They're separated with dashes, so it does that. It's basically just does some things, and then unite goes the opposite direction, right? If you have data in multiple columns, but then you want to like paste them together, you can do it this way. But it's not really any different from taking columns of data and then running the paste command. The paste command takes text data and just glues them together, right? So we have that, okay? So that's unite and separate. I would say these are less often used than the gather and spread, okay? But, so, you know, make sure you understand gather and spread, and you'll have an exercise in this week's homework, or, you know, this in homework 3 that makes you use one of these operators here. Okay. All right. Well, if that's good with tidyr, then we'll get started in dplyr, and I'm not sure how far we'll get. We've got looks like 12 minutes left, but you know, we'll start here. Okay. So dplyr allows us to take data that's nicely formatted in tidyr, but, well, I mean, anything really, and it just allows us to kind of transform this thing, okay? So you'll want to load up library dplyr, and we have several verbs. We've got select, we have filter, we have arrange, mutate, and then group by and summarize, okay? These two really go hand in hand here. I don't know why he includes this. We didn't even touch this data set here. All right. Select is for choosing variables. Filter is for choosing rows, Okay, select chooses variables, filter chooses rows. Okay, and so in this case, or filter would be for choosing observations. Okay, mutate basically creates new columns of variables is what mutate is for. And then summarize, yeah, it says change the unit of analysis, which means we're going to go from you know, one row per observation, but now you're going to kind of group those observations together. Summarize basically just takes a bunch of observations and turns it into one. All right, so let's take a look at select. Select is easy. You just take the data set, in this case storms, and then you just name the variables you want to select here. Okay, so here I've got select storms and pressure. You know, I often just start with the data name, and then I just pipe it into select, and then here I want to select storm and pressure, and there I just select those two columns. Okay, and again, if you aren't sure, it's always helpful to say, you know, what are the names in my data set, and you can see exactly what you have. All right. Just like, and notice when you're using select, you don't have to put the name in quotes. You can, but you don't have to, right? So I could say select quote storm and pressure, and it works. But you can save a few seconds by saying just that, okay? And then just like in subsetting things in R, you can put a minus sign and it will select everything but that column. And then dplyr is also smart enough where you can use kind of this colon form, and you can say, I want to select the columns wind through date, okay? And it will say, and it understands that you mean wind, pressure, and date, okay? And of course, you can specify using the column names as well, right? Or the column indices. So I want columns 2 through 4. That, of course, works as well. Okay. So when you have when you're doing select, you can say stuff like that. There's also neat things such as contains, ends with. You can say select everything or matches, and things like this, right? So these, so you can say, if we look at names of storms, all right, so you can say select contains a D, okay? And so here it says wind has the letter D and date has the letter D, okay? And so you can select columns based on what it contains. You can also have like ends with the D, or ends with the word sure or something like that. And so if you have multiple columns, such as it's like departure, like arrival time, departure time, or something like that, you can say contains the word time or ends with time or something like that, and you can select columns that way. So these are neat little things, and these are functions that come with dplyr. They're not part of base R. So you have ends with and starts with, or you know, one of, things like that. We have filter. Filter selects rows out of the table here, okay? So in this case, it's kind of like subset, except it's dplyr, so probably superior. So we would say, you know, take storms, and what we want is we want wind to be greater than or equal to 50, okay? And so basically it subsets, or it just selects the rows where wind is greater than or equal to 50. If you want multiple conditions, you can just separate that with a comma, and they are treated as an and. Okay? So in this case, I've got filter storms where wind is greater than or equal to 50 and storm is in the set of names Alberto, Alex, and Allison. Okay? So if you have multiple conditions, you just throw them into filter and it uses it as an or. I'm not or, an and. Okay? So in this case, because Arlene is not in this set of names, it's not selected. Yeah, question.
Would you be able to save the resulting table?
Yes. Okay, yeah, all of the, yeah. It would not be very useful if we can't. So, yeah, you just say like, I don't know, you call this, results or something, and you just throw this at the beginning. So you just do results, and then is equal to, and there you go, and now here are the results. So a lot of times I will often start with results, and then I'll do storms, and then I'll say I want filter where wind is greater than, I don't know, 45, and I might, or I don't know. Yeah, you can do it this way, that the storm name is in Alberto. You gotta put this in quotes now. All right, so well, this is only, and let's see what our results are. Okay, so there we go. Storm Alberto. What? Well, I guess in this case, is not very useful. I should have just done is equal to, and then that would also work as well. All right. So you got you have filter that way. So multiple conditions, you can throw them into the same filter, and they're all treated as an and. Okay. And again, if you wanted to have an or, you can throw that in here as well. So let me just kind of have this, and you can throw in if you want to change it into an or statement, you can have this, and then it will work now. Okay, so if you want to have it as an or statement, you can throw that into filter as well. But normally with a comma, it just means we want this and this to be true. So there you go. You got this as an or. Okay, and so I think we're probably used to these kind of comparison tests here. Mutate allows us to create new columns. All right, so we would say mutate storms, and so here are the columns that we have: storms, wind, pressure, and date. And we're going to say, you know what, make a new column called ratio, and that's going to be the result of taking the pressure divided by the wind. So we just do ratio is pressure over wind, and it creates that column here. Okay. If mutate is smart enough to know that if you created a new column here, you can use that name and use it in the next column. Okay, and so you can say inverse is equal to ratio raised to the -1. Okay, and you don't have to make an intermediary table where first we created this one, and now that I've created this one, then I can reference it and say, and there's a new column called inverse, which is take the ratio column and and raise it to the -1 power. Whereas normally in R, if you just created a column, you cannot in the same command make use of that column. You have to wait for it to have been created, and then you can apply functions to that. So mutate allows you to kind of create multiple columns on the fly there. All right, so that we've got mutate. With mutate, we have, an important thing to understand with mutate is you are creating a new column, so each row needs to have its own value after you've mutated it, right? So with ratio, it's doing this. It's doing vectorized operation, and so you would need to have something such as you can't just have mean in a mutate, okay? Because a mean takes a bunch of values and turns it into one, okay? Or you can't have a sum because it takes a whole bunch of values and it turns it into one. But you can do cumulative sum, right? So if you have the values 1 through 10, you can do cumulative sum, of 1 through 10. And that's going to return 10 values, and it's going to go 1, 3, 6, 10, so on and so forth, okay? So you need, when you're doing mutate, you have to keep in mind, you can't just create a column of things like the sum or the mean, because those are summary functions. They take multiple values and return 1. You need to have a one-to-one correspondence between the values in the other column. Each row needs to have its own value in mutate, after mutate. So you need things like cumulative, sum, and things like that, okay? These are called window functions because they go directly across, right? So cumulative sum, you would have 1 through 6, and it creates the values 1, 3, 6, 10, 15, and 21, okay? So, yeah, so we'll end here today talking about mutate, and then on Wednesday we'll talk about summarize, which is a really powerful function in dplyr as well.